In this video, we're going to continue to discuss ionic compounds. And in ionic compounds, we're looking for a metal atom and a non-metal atom. The metal atom gives away its electrons, outer electrons, to the non-metal atom, forming ions. Therefore, we get the name ionic compound. Now, earlier, we discussed the split in the periodic table with this stair-step line and the metals on the left-hand side wanting to lose electrons and the non-metals gaining electrons. There are also substances that will group together to form what are called polyatomic ions. In this video, our primary purpose is to study polyatomic ions and become familiar with polyatomic ions. Polyatomic ions are groups of atoms that form an ion by losing or gaining electrons as a group of atoms. So instead of a single atom losing electrons or a single atom gaining electrons, instead it is a small group. Poly, the prefix standing for many, and then atomic standing for atom. So many atoms together forming an ion. On the back side of your periodic table, we have a chart called the polyatomic ion chart. These are not all polyatomic ions that exist, but these are the common polyatomic ions that we will use. So what I want to do is look at this list and analyze what it means to be a polyatomic ion. So first off, let's look at one of the common ones, sulfate. Sulfate shows SO4 with a 2 minus. So if I write the name sulfate, here's what sulfate means as an SO4 2 minus. What it means is that there is one S connected with 4 O's, and as that group of atoms, the entire group of atoms will lose 2 electrons. I apologize, will gain 2 electrons as a group, as a 2 minus. I think earlier I said that it's most common that these group of atoms form positive ions. They don't. They typically form negative ions, so I want to clarify that by gaining electrons. Most of these groups of atoms are gaining electrons. So instead of just one atom gaining 2 electrons, it's just simply a group of atoms gaining 2 electrons. So just as sulfur in column 6A becomes a 2 minus, sulfate as a group of atoms, 1s with 4 O's, adds 2 extra electrons into that group to become a 2 minus charge. If we looked at nitrate, NO3 minus, the name nitrate refers to 1N with 3 O's, and this grouping of atoms, the 1N with the 3 O's connected together, For some reason, and we will learn this next unit, why SO4 wants to gain 2 electrons, but NO3 only wants to gain 1 electron. This is not something that we will need to memorize. We will be able to use this chart, look up the name nitrate, look up NO3, and see that it is a 1 minus charge. This group of atoms, 1N with 3 O's, behaves as a halogen, where we know that everybody in column 7A is a halogen. They all have 7 valence electrons, so they all become a 1 minus, F a 1 minus, Cl a 1 minus, Br a 1 minus, I a 1 minus. So for some reason, and we will find it out next unit, this 1N and 3 O's likes to add 1 electron on as a group to the group of atoms, likes to add 1 electron on to become a 1 minus charge. Another common one is phosphate. Phosphate is a PO4 with a 3 minus. Phosphate. 1P with 4 O's, and it's got a 3 minus charge. So when we write it, 1P with 4 O's, and we'll find out next unit why it likes to add 3 negative electrons. This group of atoms behaves as a single element that would be in column 5A. Each one of these elements in column 5A have 5 outer electrons. They want to gain 3 electrons to fill up their outer energy level and become a 3 minus. This group of atoms, 1P with 4 O's, behaves the same. It wants to gain 3 electrons to become a 3 minus charge, and we call that a phosphate. This group of atoms wants to gain 3 electrons. As you can see from the chart, on our common chart, all of these are negatively charged, wanting to gain electrons, except for this one, ammonium. Ammonium is a group of atoms that forms a charge, so we call it a polyatomic ion, 1N with 4 H's, and as a group of atoms, it wants to lose 1 electron. It wants to lose 1 electron to become a 1 plus ion. On this periodic table, that 1N with 4 H's behaves as a single element from column 1A. All of these metals, Li, Na, K, Rb, Cs, Fr, all want to form a 1 plus ion because of their 1 outer electron. Well, the group of 1N with 4 H's wants to behave similarly and loses that 1 electron out of the group and becomes a 1 plus ion. In dealing with polyatomic ions, there will be some new rules that we will go over regarding how we put the metal together with the group of nonmetals, or the positive ion with the non-metal. And we will be going over those rules during the next video. But I want to remind you that when we're dealing with polyatomic ions, it's just simply a group of atoms that form an ion. Many atoms coming together, and then as a group gaining 2 electrons, or as a group gaining 1, or as a group gaining 3, or as a group losing 1 electron. Polyatomic ions. I hope this helps with understanding polyatomic ions.